At 1:19 a.m., a voice spoke 12 calm words.
Good night, Malaysia, 370.
Then, silence. A silence so complete it swallowed 239 lives. But silence is never absolute, because buried inside the static was one last pulse, a digital heartbeat, a transmission no one understood, until now. For 11 years, investigators believed that was the end. But what if it wasn't? What if the plane's final transmission was more than a goodbye? What if it was a message hidden in mathematics? March 8, 2014. Flight MH370 departs Kuala Lumpur, bound for Beijing. A routine red-eye through the night sky. At first, everything behaves as expected. ACAR's signals report healthy engines. Radar shows steady climb, clean trajectory. Then, 1 minute past 1:19 a.m., the transponder vanishes. No mayday, no system failure report, just absence. Controllers assume a glitch. Then, a military radar picks up an impossible trace. The aircraft turning west, against its filed route. Crossing peninsulas, climbing again, then diving into darkness. The plane that should have been over the South China Sea was now flying toward the Indian Ocean, untracked, unseen, for 6 more hours. When every system goes dark, there is one network that sometimes keeps whispering, the satellite link. Every hour, a brief digital handshake. A ping confirming the aircraft still exists. A whisper across the void. And in those whispers, engineers later found something strange. Tiny distortions in frequency, subtle shifts in timing, irregularities too consistent to be random. Those distortions were the key to the arcs, the invisible tracks that mapped the aircraft's ghost flight across the planet's emptiest water. But one transmission didn't fit, the very last one. 8:19 a.m. local time. A signal unlike the others, a signal that refused to be explained. That final burst wasn't routine, it wasn't even expected. It was a log-on request, as if the aircraft had momentarily died, then tried to wake itself again. To some, it was mechanical, a backup generator coming online. To others, it was deliberate, someone rebooting systems in the dark. Either way, it became the last known act of MH370. For years, that fragment sat unsolved, buried in archives. Now, AI pattern recognition, signal decoding models, and resynchronized satellite clocks have revealed something new within that data. It wasn't just a handshake, it was a pattern, a sequence, a final transmission, finally decoded. If the interpretation is correct, then MH370 didn't vanish into silence. It spoke in the language of its own collapse. A digital distress call no one knew how to read, until now. The human ear hears nothing below the waves, but machines do. And what they found changes everything. For years, investigators stared at radar plots and satellite handshakes, patterns drawn in the air. But the ocean had been recording something else all along. Not with microphones, with pressure, motion, and radio. The final signal didn't just travel upward to the sky, it echoed downward, into the very medium that would one day reveal it. The breakthrough began not in a control room, but in a lab on the edge of the Indian Ocean. Autonomous drones, AUVs, were being prepared for a new kind of search. They weren't built to find wreckage. They were designed to read patterns too faint for humans. Sonar interference, radio reflections, and hydrodynamic disturbances. The fingerprints of a crash buried beneath 6,000 meters of water. Each AUV carried a payload of sensors, synthetic aperture sonar for millimeter detail across miles. Inertial navigation that mapped trenches with sub-meter accuracy. And a new experimental array called a hydrosonic vector field, capable of detecting vibrations left by solid metal even after years of sediment drift. In effect, the drones were listening to the ocean's memory. Because water never forgets impact. To understand what they were looking for, engineers first revisited the last transmission, the 8:19 a.m. log-on request. It lasted less than a second. But inside that second were micro variations, tiny timing offsets and irregular amplitude spikes. In 2025, a team fed those anomalies into a neural network trained on years of aviation telemetry. The results stunned them. The AI detected non-random modulation, a flicker that matched electrical surges consistent with a structural breakup or violent depressurization. In other words, the plane may have been transmitting as it failed. A machine's reflex, captured in a mathematical gasp. But verifying that meant locating a physical echo, a place where the signal and the sea intersected. When a radio wave travels through the ionosphere, part of its energy disperses downward. Over the open ocean, that energy can penetrate the upper layers of water, creating faint electromagnetic ripples. Those ripples interact with underwater terrain, ridges, metallic structures, even wreckage, producing measurable distortions in sonar backscatter. For a decade, those distortions were ignored as background noise. Now, they're being reinterpreted. When Ocean Infinity's upgraded AUVs swept the Seahorse Zone in 2025, they logged not just terrain data, but faint anomalies in electromagnetic reflection. Patterns that matched the frequency signature of MH370's final handshake. It appeared the plane's last signal had left an imprint in both mediums, the air and the sea. To test it, engineers synchronized satellite time codes with deep-sea sonar timestamps, a cross-reference never attempted before. When they overlaid both datasets, one spike aligned perfectly, 8/1937. That was the exact second of the plane's final log-on attempt. And that same moment, 5 kilometers below, the sonar registered a micro-echo, a reverberation impossible to fake. For the first time, data from space and sea spoke in unison, a system failing above, an echo answering below. If this synchrony is real, then the ocean isn't just where MH370 rests. It's where its final message was stored, waiting 11 years to be heard. But what, exactly, did that message say? Was it physics or intent? Before the data, before the drones, there were faces, waiting, listening for an answer that never came. For 11 years, the search for MH370 wasn't only about sonar sweeps or satellite math. It was about people learning to live with silence. In the world's longest investigation, the ocean wasn't the only thing that refused to give back. So did time. In airports from Kuala Lumpur to Beijing, waiting rooms became sanctuaries of uncertainty. For some, the last message from a loved one was a text, "Boarding now." For others, a photo of a window seat. Every small digital trace became sacred. Days turned to months, months to years. And as the official searches ended, the families refused to. They built their own networks, online groups, independent analysis teams, citizen cartographers scanning satellite imagery pixel by pixel. They raised funds, petitioned governments, demanded transparency. And every time another search was suspended, the same question echoed. If technology can find planets orbiting distant stars, why can't it find a plane on our own? Not everyone moved on. Some investigators kept the case alive long after the budgets ran out. Data analysts, oceanographers, radio engineers, men and women who refused to accept that a machine could disappear into math. They worked from garages, universities, late-night labs lit by blue monitors. One researcher described it as listening for a ghost through the noise of the sea. Others turned their grief into expertise. Relatives learning code, scientists learning compassion. Across continents, they began sharing data directly, bypassing bureaucracy entirely. By 2024, when Ocean Infinity announced its return to the Indian Ocean, something remarkable happened. Volunteers, families, even independent researchers began contributing directly to the mission's data sets. They weren't just observers anymore, they were collaborators. AI drift models built by students, crowdsourced simulations refined by retired pilots, families reviewing sonar maps line by line, searching for anomalies. For them, the ocean wasn't a scientific problem. It was a promise that truth still existed somewhere below. When the Armada 7806 launched its new fleet of drones, many of the people watching the telemetry feed weren't engineers. They were the same families who had once stared at arrival gates. And then, 11 years after that final radio call, the silence broke. A single sonar return flickered on screen, an anomaly too structured to ignore. To the engineers, it was data. To the families, it was something else entirely. Hope, mixed with terror. Because finding something means confronting what's been lost. Some wept. Others refused to believe. After so many false alarms, hope itself had become dangerous. The human story of MH370 was never about the moment it vanished. It was about the years that followed, when silence itself became the search engine and grief became data. Psychologists who studied the families of MH370 coined a new term, ambiguous loss, a grief without evidence, a mourning that never ends, because the mind can't finish what the sea never confirms. For the families, the new evidence brought both relief and fear. Relief, because technology had finally reached where humans couldn't. Fear, because proof of wreckage means proof of finality. It's a paradox. The closer we get to truth, the harder it is to bear. But emotion alone couldn't solve the mystery. For that, the search turned back to logic, to the raw, cold precision of machine learning. And that's where the next discovery would begin. When the first images returned from the deep, they seemed unmistakable. Straight lines where there should be none. Angles too perfect for geology. But the ocean plays tricks, and data, like light through water, can bend. So before the world could celebrate a discovery, the analyst had to answer one question. What exactly were they seeing? In Houston, Perth, and Singapore, 3 teams looked at the same sonar frames and saw 3 different truths. To the robotics engineers, the pattern resembled a wing segment, roughly 30 meters long, half buried under sediment. To marine geologists, it looked like a rockfall formation, carved by centuries of underwater currents. And to data scientists, it was simply an anomaly in resolution, caused by overlapping sonar paths. One data set, 3 stories. And in the middle of that noise, a machine trying to choose between them. The AUVs used a learning model called convolutional subsea pattern recognition, trained on millions of underwater structures. Its job, detect what human eyes miss. But artificial intelligence doesn't know truth, it only weighs probability. When fed the MH370 data, the algorithm produced a split result. 72% confidence, man-made origin. 28% natural formation. That's not certainty. It's the statistical version of a raised eyebrow. For the families waiting above, numbers like that might as well be silence. Some researchers believe the new sonar images show a fragment field, debris scattered by impact and later shaped by currents. Supporting clues, irregular spacing, varying object density, and reflective patterns consistent with composite metals. If true, it suggests a high-energy crash, a violent descent, the aircraft breaking apart before reaching the seabed. It would align with the 2018 descent rate models and explain why so little debris ever surfaced. But there's a flaw. If the crash was that catastrophic, why do several shapes remain intact and aligned? A second theory claims the opposite, that the structure is largely intact, a fuselage lying on its side, preserved by low current and silt. Its supporters point to symmetry, parallel ridges matching cabin frames, a shadow resembling a vertical stabilizer. They argue this indicates a controlled descent, possibly a deliberate ditching. The implications are profound. If the wreck is intact, the black boxes could still be sealed, their memory units readable. It would mean someone guided the aircraft to its final rest. But others warn of confirmation bias. When you want to see an airplane, every ridge becomes a wing. Then there's the most sobering possibility that the shapes are an illusion, a false echo. Underwater acoustics can betray even experts. Temperature layers, salinity gradients, and the ship's own propeller noise can create ghost reflections, echoes that appear solid but aren't. During the 2018 search, similar anomalies led teams to chase phantom targets for weeks. Each ended in disappointment. Volcanic ridges mistaken for wreckage, coral mistaken for fuselage plating. If this new data is another mirage, the emotional cost will be immense. To resolve the conflict, Ocean Infinity's analysts built a cross-validation model, combining sonar, magnetic readings, and WSPR signal mapping. The AI compared thousands of underwater shapes across known crash sites worldwide. Only one matched the new structure's geometry with over 90% similarity, a submerged aircraft frame from a test simulation off Norway. It's compelling, but 90% is still not 100%. And in mysteries like this, the last 10% is everything. By early 2025, a fragile consensus emerged. The sonar anomaly is likely related to MH370, but confirmation will require a camera, a sample, a human-verified image, and that means one final descent. Not of an airplane this time, but of a machine built to see what light never reaches. The ocean had spoken in code. Now, someone had to go down and listen in person. At 6,000 meters below the Indian Ocean, there is no day, no night, only pressure and silence. Down here, steel bends like wood. Down here, light itself expires after a few meters. And into that void, the drones descended. They weren't searching for debris anymore. They were searching for memory. In early May 2025, Ocean Infinity launched the Armada 7806, its most advanced autonomous research ship. No crew, no pilots, just algorithms, sensors, and the quiet discipline of machines that never sleep. From its hull, a cluster of AUVs detached, sleek, torpedo-shaped, their titanium bodies gleaming in the floodlights. They sank, one by one, guided by inertial maps and satellite coordinates derived from the Decoded WSPR data. Each carried multiple eyes, high-resolution synthetic aperture sonar, laser altimeters, and optical cameras designed for crushing depths. Their target, the anomaly detected months earlier. At 2:47 a.m., the first AUV, Unit 3, reached the seabed. Visibility, 6 meters. Silt clouds drifted like fog. The drone swept its light in slow arcs, recording each contour. At first, nothing. Just rock and sediment. Then, at 2:53:16, a shape appeared. Flat, metallic. Edges too sharp to be natural. The feed went quiet. Every control room, every observer watching the stream, held their breath. As Unit 03 circled the target, the floodlights revealed what sonar had only hinted. A curved edge, a torn seam, rows of evenly spaced ribs along one side, unmistakable. It looked like a section of wing. Engineers compared dimensions in real time. Span, chord, and taper angle, identical to the right wing of a Boeing 777. For the first time in 11 years, they were no longer staring at theories. They were staring at evidence. 2 more drones joined the grid. Their sensors triangulated the find, then pushed outward. Within 400 meters, a second object appeared. A large cylindrical section with a concave edge, the remains of a fuselage midsection. A third shape lay 200 meters further, fractured, hollow, half buried in sediment. It wasn't scattered debris. It was a field. A pattern consistent with a breakup sequence, not a freefall. To investigators, that meant something profound. The plane likely struck the ocean at a controlled, shallow angle, breaking apart over seconds, not milliseconds. Back on the surface, data from the drones streamed into the ship's AI core. Each new frame was cross-referenced with the reconstructed flight path derived from WSPR signal propagation. The vectors matched, within 0.3 nautical miles. The location fit every independent model, every drift simulation. Probability of coincidence, less than 1 in a billion. After 11 years, the math had finally found its proof. Before any announcement, verification began. Material density, alloy composition, serial engraving. The fragments were layered composites, carbon fiber reinforced polymer bonded with titanium spars, the exact materials used on the MH370 airframe. Every line of evidence converged. But with every confirmation came a deeper unease. If this was indeed the wreck, then the final signal, that 1-second log-on, was not random noise. It was the aircraft's final reflex, the echo of a machine trying to stay alive. News traveled fast. Families who had spent a decade in limbo gathered once again, this time before screens, not arrival gates. For some, tears. For others, silence. Closure can feel like a wound reopening, because knowing where something ended isn't the same as knowing why. The drones had found something real, but in solving one mystery, they awakened another. Because deep in the data, hidden inside that final transmission, was a pattern no one expected. One that might change everything we thought we knew about MH370's last moments. For 11 years, the final ping from MH370 was treated as noise, a glitch in the system, a meaningless digital heartbeat. But when engineers reprocessed the data using modern AI, the noise began to speak. Inside that 1-second burst, something was repeating, not random static, a pattern, a code. In mid-2025, signal scientists fed the raw satellite handshake data into a new decoding model called recursive signal contextualization, software capable of reconstructing corrupted transmissions using predictive neural mapping. They aligned the timestamp, 8/1937, the final logon request. Then they slowed it down, magnifying the burst by a factor of 10,000. What emerged wasn't a steady curve. It was pulsed, uneven, staccato, like Morse code with missing beats. At first, the team assumed equipment interference, but when the sequence was cross-checked with the aircraft's internal systems logs, the pattern matched something eerie: the automatic power-up sequence of the SDU, the satellite data unit, rebooting after total electrical failure. In other words, the plane had gone dark and was trying to wake itself. When the backup generator activated, the SDU attempted to re-establish contact with the satellite network. But here's what puzzled analysts. The reboot sequence should have lasted milliseconds. This one lasted over a second. That's an eternity in avionics. And during that second, the output fluctuated in amplitude, as if something was interrupting the signal, rhythmically, 4 times. AI signal analysis converted those fluctuations into a visual spectrogram. The result looked like a heartbeat. 4 sharp pulses, then silence. Some saw an electrical oscillation, others saw something else, a pattern that looked deliberate. The first interpretation was mechanical. Engineers suggested the 4 pulses reflected the sequential ignition of auxiliary generators, the aircraft's final attempt to maintain basic power. It fit the known data. Fuel nearly depleted, left engine flameout, right engine seconds behind. As the engines failed, the plane's systems flickered. The SDU rebooted, broadcast the handshake, then went dark forever. That explanation satisfied the math, but not the emotion. Because another team saw something more in the rhythm, something human. At a separate lab, signal reconstruction experts compared the amplitude pattern to cockpit electrical sequences, specifically manual reboot intervals. The timing was nearly identical to what would occur if a pilot, in darkness, tried to restart the satellite link by hand. If true, it would mean someone was alive in that cockpit at 8:19 a.m., trying to reconnect, trying to send one last signal, even if it was only data. But if that's the case, then what happened after that moment? Why was there no follow-up transmission, no distress call, no flight data burst? The only possible answer: whatever happened next was catastrophic, sudden, final, irreversible. A third theory goes further, that the signal itself was a distress marker. Researchers noticed that within the transmission's digital checksum, the mathematical signature that verifies message integrity, 2 bits were inverted, forming an error pattern identical to a distress frame used in legacy aviation code from the 1990s. Coincidence? Or a desperate system sending what little it could before total failure? If accurate, this would make the 819 burst not just a handshake, but a cry for help hidden in binary. To the families, it hardly mattered which theory was right. What mattered was that the plane hadn't vanished without a trace. It had spoken. For years, silence was the symbol of this tragedy. Now that silence had been decoded, and inside it, a pulse, mechanical, mathematical, maybe even human. But this discovery raised a larger question, not just about MH370, but about every machine humanity sends into the void. If our systems are capable of leaving hidden signatures, messages we can only read years later, then what other truths lie waiting in our data, unheard until technology evolves enough to find them? Perhaps every disappearance leaves an echo, and perhaps decoding that echo is not about finding loss, but learning how silence itself records memory. The final transmission had been decoded, but the meaning behind it, whether mechanical or human, remains unanswered. And so the investigation turns one last time, from the data to the depths. For 11 years, the world stared at the sky, searching for answers that were never up there. They were down here, in the quiet pressure of the deep, in signals too faint for the living to hear. Now, the ocean has spoken, and we are still learning what it's trying to say. The drones proved what grief and science had long suspected, that truth doesn't vanish, it just hides beneath new layers of noise. Finding the wreckage doesn't end the story, it reframes it. For aviation, this changes everything. New systems are being designed to transmit black box data in real time. AI-driven search protocols will make it almost impossible for another aircraft to vanish so completely again. Yet for the families, progress feels bittersweet. Technology can reveal the how, but not the why. As decoding methods grow more powerful, another question surfaces. How much of tragedy should we digitize? AI doesn't grieve, it processes. But when machines decode the last seconds of a human catastrophe, who decides what should be revealed and what should remain unseen? Data can tell us how a plane fell. It can't tell us what the people inside felt. And maybe that's something only silence should keep. In 2014, a flight disappeared. In 2025, the machines that once failed to find it learned to listen differently. Each sonar ping, each radio flicker, each byte of corrupted code became part of a global algorithm, a collective effort to teach technology empathy through precision. MH370 is no longer just a mystery. It's a mirror, reflecting how far we'll go to reclaim the voices we've lost, and how even the coldest data can carry warmth when read by human hands. Every sound ever made in the sea still moves within it. Whale song from a century ago, the hum of ships that no longer exist, and now the faint metallic echo of a Boeing 777's last breath. The ocean doesn't forget. It just waits for us to learn how to listen. Perhaps that's what MH370 has been trying to tell us, that every disappearance is temporary until understanding catches up with time. In decoding the final signal, we didn't just find a plane, we found a pattern of resilience, of curiosity, of humanity refusing to accept silence as the final word. Maybe the message hidden in that last transmission was never meant for satellites. Maybe it was for us, a reminder that even in the deepest dark, the search must go on. The ocean remembers. The question is, will we listen the next time it speaks?